So now, if we're taking a look at more configuration type ideas, the next thing we talk about is noble gas electron configurations. So whenever we're dealing with elements, the goal is always that they're striving to become like these noble gases. That's these green elements over here. So helium, neon, argon, krypton, xenon, and radon. All these guys are noble gases. They're some of the most stable things on the periodic table. So most things are trying to be like this column over here. Our last group, these are the noble gases. Again, they're some of the most stable things on the periodic table because they have a complete orbital every single time without changing anything. So, if we're trying to write an electron configuration based on our noble gases, let's pick something. Let's say that we're going to write the noble gas configuration for something like calcium. So, the closest noble gas to calcium is actually the one that occurs prior to. So, calcium's 19, potassium's 20, potassium's 19, so argon is the one that occurs before it. Argon happens to be the closest noble gas. So if I'm writing a noble gas electron configuration, I always pick the noble gas that's closest, or to put it more simply and to put it a little bit clearer, we always pick the noble gas that comes prior to our element. So calcium is number 20, argon comes prior to our element. So noble gas electron configuration really is saying that we have that noble gas electron configuration plus a couple of extra things. So again, we're writing the noble gas electron configuration for calcium over here. So we know that calcium has the electron configuration of argon plus something extra. So if we're in argon here, we're trying to get to calcium. We also know that calcium's got 1, 2, 3, 4th row, and it's the second thing in the s orbital. So the noble gas electron configuration for calcium would be argon plus 4s2. That tells me that the electron configuration for argon is built into this plus 4s2. So we go argon a little bit further and we get to calcium here. If we're trying to pick something that's a little bit different, let's say something like bromine. So bromine over here, again, we have to pick the noble gas that comes before it. So the noble gas that comes before bromine is actually argon again. Because remember, it's always the noble gas that comes prior to our element of interest. So right now, bromine is the thing we're looking at. The noble gas that comes before it is argon. So even for bromine, we know that the electron configuration for argon is built into here, plus it's got some extra stuff. So argon plus 4s2 plus this row right here. So remember, D is one row lower than what we think it should be. So this is actually 3d10 as we get all the way to the end over here, plus a little bit more. So it's the 4th row. We're in the p orbital, and it's 1, 2, 3, 4, 5 things. So there's our noble gas electron configuration for bromine. This is actually also a really good indicator for why electronegativity works the way it does. Keep in mind that the goal of any element is to really make sure that we kind of look electronically like a noble gas. So in order for calcium to look something like argon, it would have to lose those 2 electrons. If it loses those 2 electrons, it looks a lot like argon. It's very happy, it's very content. So it's really ready to get rid of these 2 electrons in order to look like argon. That's why it has a low electronegativity. Bromine, on the other hand, wants to look like a noble gas. So there's a couple of things can happen. Either it loses everything that we wrote here in order to get to argon, or it picks up 1 more electron to look like krypton. It's why bromine has a higher electronegativity than some other things, because it just needs 1 more electron and it'll look like krypton, its next door neighbor over here. That's why bromine has a high electronegativity, and it's why calcium has a low electronegativity. Calcium loses 2 electrons, it looks like a noble gas, it's content. It doesn't really want those electrons. Bromine, on the other hand, wants to hang on to all of these and gain 1 more, because then it'll look like krypton, at least electronically speaking.